So, yeah, hello everyone. I'm Luca and CTO at Broentech Solutions. Some of you may already know me from before. So today I'm going to introduce a little bit the frameworks that they are present in when you're developing models, AI, or yeah. So and in particular, we will go to see about what type of tools are already available and why you should use it, and what are the strengths and of each one of them. I try to be not too much technical, but there is some technicalities, but yeah, try to make it, let's say, a smooth introduction for Duo presentation, which will be a little bit more detailed. So the first question that you may ask, so some of you are interested in AI and they want to start to, get their hands dirty and start to program a little bit. So where we should start? Why I cannot just start? I'm a very good C++ programmer. Can I just avoid using all the tools, all the frameworks? Potentially, yes. You could potentially write everything by yourself, starting from scratch, using only the standard library. But the problem is that you need really to write everything. This means that you need functions for writing tensor operations, matrices. You need to have calculating gradients and things like this. So practically you should not do that. So the alternative is actually to use frameworks, which are library, which are already available out there, and they already implement most of the functions that you want, that you may need. So you can see that, for example, it's very easy to write code with it because they already are prepacked most of the functions for you. And they include all the parts that you may need. So, for example, you can just directly import gradients. You can already directly calculate gradients, for example, or import layers for your deep learning models, or even import complete networks already. Also, if you try to write the code by yourself, you will definitely be not optimized at all. So these functions, these frameworks, they already have very high efficient operations, and they have GPU support. So if you want to train your very huge networks, you can do it on GPUs, which is way faster than normal CPUs. Also, if you do everything by yourself, then you can ask questions that you have on yourself, and this usually does not work very well. It's better to have a community out there where to refer to. And that's basically, you get a very huge community support there. So all your questions that you may have, someone else already asked for it, so you just have to go and read out for it. I try to get some 8 of the most popular frameworks. So we'll see, we'll not go too much in details because we don't have much time, but at least I give you some sort of presentation of them. And then on the second part, we'll use the last 10 minutes to see what you can do with it and how you can abuse it for those type of models that you can build. So the first one is Caffe. Caffe is it was a very popular tool. I reported here mostly for historical reasons because it was developed by Berkeley University in 2015. It's completely open source, so you can just go there and just look at the code and everything. It was specifically made for image, so you could do also other stuff, but 90% of the usage was for image recognition. It was written in C++, but it has a lot of wrapper around, so Python, MATLAB, or even Shell. So you can just type the shell command directly from it and basically use it for training your network. So I said that is for historical reason. Firstly, because it was very popular, at that time, which is only 4 years ago, but seems like another era. Because now in deep learning there is before TensorFlow and after TensorFlow, so basically we use this tool for in our one of our first project using deep learning, which was the corrosion detection project. Basically we run an internal project, we run a project where with other companies to basically detect rust in bridges. So, and then we use exactly this framework. It was working very well. And before TensorFlow came out, it was really one of the only tools for working with images. But in April 2017, Facebook announced Caffe 2, which also include RNN. RNN are recursive neural network. They're used for example, finding object within an image. And then in 2008, so last year, Caffe 2 was merged into PyTorch. So now if you want to use Caffe, basically just use PyTorch. So it includes everything there. Just a quick, so don't get scared. It's the way how it was working is that you are creating a JSON with your network definition, basically, and then you are using that network definition for your network, you know. So where you are creating the network, for example, within Python, you know. And then you see, and then you could one cool thing. So you are doing some pre-processing here, and then forward. One cool thing is that you could save the models. The model of Caffe were pretty, they were kind of a little bit like a standard. You can also import it in other frameworks. So it was very, very powerful. So, but now it's basically almost gone. No one is using anymore because it's been merged with PyTorch. Basically, PyTorch is developed by Facebook. Also very, very, very popular. Basically, it's a Python port of Torch. Torch was another framework, was written in Lua, but now basically then Facebook took over and basically create this port, written in Python, and it's extremely powerful. It's what we use in Tide, in Broentech. And also works with images, text, speech, so you can basically draw whatever, you can build whatever things you want there. And there is some very cool features about this, is that use dynamic computational graph. This means that the graphs does not have to be defined at compile time. So basically, it's just, you can just, the graph is basically, is not static, so you can actually, it's dynamic, so it's very, very powerful. The drawbacks about that is that some people think that it's not extremely suitable for production, and the reason is because you don't know how much memory is going to consume statically, you know, so it's a little bit like that, but we don't have any problem running this in production, so don't be afraid of it. So the example, this is how the code look like. You can see there is some cool features that you can, for example, track computation with required gradients, and then the framework automatically start to track all the operation that you are doing, and then at the end you can just, for example, computate it backwards, and the auto gradient will automatically fix everything for you, and you can already print out the gradient. So you don't need to propagate each layer. There is already the framework which does this for you. Very, very powerful, very, very convenient way for doing that. Then we have TensorFlow. TensorFlow is developed by Google. This was already breakthrough in 2015, I think. No, 2016, something like that. And it was a very, very powerful tool which has been released open source, and this has changed everything basically. So it's very low level, especially the version 1, and because it's so powerful that you can really change everything, you know, like each single details of the network, for example, you can implement by yourself. The cool things about when it came out is that it was already supporting distributed computations. In this case, for example, like you could not only training in one machine, but you could use multiple machines. This was very cool at that time. Now including PyTorch, also PyTorch supported, so it's something less more normal. But when it came out, indeed it was so innovative that they didn't release. They released after 1 year the distributed training features. There is a great community support, so there is a lot of people using TensorFlow, so the community is one of the biggest. So I said that TensorFlow changed everything, and it did, because let's say before TensorFlow, mostly of the tools and the frameworks were developed. It was basically research, so they were basically developed by universities. For example, we'll see like Teano one, or for example Kafka, they were developed by university and they were using it. But then with TensorFlow, all the big companies start to step in the AI thing. So basically all these new tools arrived and they kind of killed all the other small tools that they were around before. This is how the code look like. You can see that this is for TensorFlow 1. You can see that actually you need, and this is also why you use TensorFlow. There is a very big difference between PyTorch and TensorFlow. Is this use static graph computation? So you need to define your network before you actually start to use it. So yeah, and you can see that in TensorFlow 2.0 that you don't have session anymore. So the code is a little bit easier. But because you can see that it's pretty low level, so there is a lot of things that you need to set up before you train your network. There were other tools that they came out, and the most powerful is Keras. So if you are really new at basically neural networks, you should definitely look into that. And especially if you know Python, you will love this. This is something because it's very high level. So you don't really need to be a mathematician for to set up all these small details. You can actually just import layers or completely models and start to play around with it with just very few lines of code. So this is it's kind of a library which run on top of other tools, for example in TensorFlow or Teano. And as I said, there are already pre-packed layers and models that you can import. Yeah, so it was so powerful. It was so popular that TensorFlow also created a kind of its own version of Keras within the TensorFlow library itself. So basically now, if you want to use Keras, you can either, this is exactly the same code, but in two different variations. Either you use Keras as a standalone library, or from TensorFlow you can import Keras. So basically they implemented the Keras functions directly inside their own libraries. So yeah, and it's very, very popular because you can see that here you can just add in new layers, but just model.add. You don't need 50 lines of code for adding one layer and define everything and then import it. So it's very, very, yeah, very, very powerful. Teano is also was developed by university. This was one of the also oldest one. It was from 2002, something like this. It's very similar to TensorFlow. Indeed, there is Keras on top, which also can interface with it. I just mentioned it because of Keras. But these are not completely replaced by TensorFlow. As I said before, when these big companies stepped in, all these tools that were, all these frameworks which they were developed by university, they kind of suffered, and then indeed they are kind of being dropped. But they are open source, so there is always someone which is continuing those projects, but they are not actively supported anymore by the huge community as was before, And also you can see a little bit the feeling of how the code was. Basically you were creating operation and then you were attaching those operations to some function, piano functions, yeah. So, but I guess that's not very relevant anymore. So if you are a Java programmer, I don't know why you should, but if you are a Java programmer, there are a couple of frameworks. There is at least one framework which is pretty good, despite it's in Java. It's very good. It's basically deep learning for Java. It's very powerful, actually. You can train like text or images or whatever, and it has a lot of APIs, including Scala, Kotlin, for example. And another very good thing is that you can import Keras models. So if you wrote a Keras model, for example, for TensorFlow, you can also import it in this tool here. Also, actually not only for TensorFlow, for any other Python supported APIs or Keras, you can import it also in deep learning for Java. So I guess this is also, as I said, it's relatively popular. I guess mostly of the people using it is because they already have no Java and they don't want to go out from it. So they actually why they use it. There is also good community behind it. The last two example which I'm going to give is about the Fast AI. Fast AI is for PyTorch what Keras is for TensorFlow. So in the meaning that is a kind of layer on top of it, which basically make stuff easier to use. You know, like instead of going too much to low details, you can still import layers and do a lot of stuff with Fast AI. Not very popular yet, but yeah, it's also because it's very new. But I reported in case someone wants to play with PyTorch and doesn't want to go too much in details about it. The last one, which I'm going to mention, is Apache MX-Net, and they advertise themselves as a production-ready framework. So it's not something that we looked too much into that, but I know that, for example, cloud providers are using already support that. For example, Amazon. It's just a production ready. So I guess if the stability is your main let's say property, then you should really give a look at this. Also because it's from the Apache Foundation. So going back, these are the tools which are now. So, and in 2015, around 2016, there was a lot of stuff going on around frameworks. You know, there were these clashing technologies that they were trying to emerge. You know. So what about the future? Do we still, if I choose a framework, will be changing like within 1 year? Well, we don't know for sure, but we can see that it's a little bit settled now. Now there is basically TensorFlow and PyTorch, which are very, very popular and powerful. So and they are supported by these big corporates, one Facebook, the other one Google. So I think like what we can see now, what is happening in the field is that there is a lot of research focused on the visualization and analysis tools. So a lot of new tools that they are coming out are for analyzing these networks, you know. Because it's a little bit sad, but still, if you have this huge, complex deep learning network that you maybe for image recognition or for text analysis or whatever, it acts a little bit like a black box, in the meaning that they are extremely hard to debug, you know. So you can only test it. For example, you can try to throw some picture on it and then see what the result is. And if it's good, then you think that the network is working. And if it's not good, then you know that the network is not working. But it's very difficult to know what is actually going on inside, why this neuron has been fired. For example, if it does not work, is it because you can't really open it and debug it? So that's why there are new tools coming out for helping developers to debug these things. So, for example, I think there were, yeah, so this was, so I think, because the problem is, I was saying that there is a problem, and the problem is that you cannot really debug these networks, because even if they give you the right results, you don't know if the network is behaving as you expect. And so for clarifying this concept, I would mention this paper, which was written a couple of years ago. So basically, they trained a network using, for example, which they were classifying dogs vs wolves, you know. So they had basically neural networks where you were throwing images, and basically the networks was predicting with 90% accuracy if it was a dog or a wolf. It was a very good accuracy. So would you trust this network? People were giving examples, and it was working. And one of the examples of the picture which was failing it was this picture, you know. So this husky was wrongly classified as a dog, you know, as a wolf, you know, instead of a dog. So then when they start to investigate better the network, you know, to look at explaining why the network, what are the features that the network was looking into, they discovered that at every picture of the dog, of the wolf, there was snow, basically. So basically, their training set, all the picture of wolves include snow as a background. And all the picture of dogs, there was no snow. So what actually built was not a dog classifier, but was a snow detector, basically. So, and it, you know, that is the things that even if the network was giving the right results every time, it was extremely difficult to debug it, to see that actually there was an underlying problem, which no one talked about that, you know. So this is something that we should not trust blindly AI, you know. It's not that, even if it works, you know, we really need to put more effort on trying to understand what's going on inside, you know. So yeah, that's the first problem. But what we can do with it? Well, so if you want to start a new company or start a new project, there are basically, when you talk about AI, there are basically two things. The first one is general AI. General AI is very far-fetched in future. There is something, a little bit, we are starting to move in the right direction with AlphaGo. The reason is because it can be generalized to other fields, you know, it can go out from the box of their specific sector and just move it to another field, for example, you know. So, and that's, AlphaGo is moving to the right direction. We are not there yet, definitely, but it's a good step. But and no one is going to fund you, basically give you money for developing general AI. So it's, I mean, as far as like most of the investors are not looking into that, you know. So this is up to big companies. But specialized AI is where mostly of the work is nowadays. So your vocal assistants, for example, the type product, our type product, which predict anomalies, and or your smart device like Netflix or like Echo Home, you know. Those things are example of specialized AI for very one specific, basically, purpose, you know. So, but the problem is that despite what you do, you really need to think about that every things that you develop can be easily abused from or misused by other people, you know. So I will present 3 examples of that. So this means that you really need to, AI is extremely powerful, but because it's extremely powerful, it can easily get weaponized, you know. So one first example is deepfake. Deepfake was a very cool project actually. I think I can show one example here.
Oh, there's no net.
There's no net? Okay.
Bring it back.
Yeah, you bring it back.
Okay.
Basically, this deepfake was that you were seeing basically a video or a picture, and it was kind of swapping the face with someone else, you know. But it was not something like the app is doing, like this network now.
You need to connect to the network called Denne.
Yeah. So. Yeah, you can see it from here. For example, this was the original image, the original frame, and then there was the frame from Nicolas Cage face, you know. So they basically, it works really good. I mean, it's very, very, very difficult to understand the difference, you know. So, and this was a very cool project in the beginning until someone started to misuse it. And for example, they start to use these. First they came this nude app where basically they were swapping the faces in some naked picture, you know, and then they start to make the videos, and of course you can imagine how this quickly escalated into something which was extremely bad. So yeah, even this was, for example, a misuse of like deep learning for video. But it's not only that. For example, OpenAI, that is a pretty cool companies founded by Elon Musk. And they trained something for writing realistic articles. They train with 40 gigabyte of data coming from internet. So this is and the way how it works is that you give an input, and the model automatically, shoot you like the rest of the text, So, for example, if you give an input, so this is from their website. So, for example, if you give an input like this, where they, in a shocking finding, basically the scientists have discovered unicorns, and those unicorn also speaks perfectly English. Well, you give this one as input, and the output, and this is the generated output from, actually part of it, I just took a brief sections from the output from the model itself, So you can see that actually not only it makes sense, it's like grammatically, and but it's also, it's actually a good article. I mean, it seems that it's been written by a person, So, so this is because, and of course, this type of technology can be easily, misused by people which they want to create fake news, for example, or things like this. So that's the reason OpenAI did not release the source code of this project, But it's very, very powerful. I mean, it's impossible to say that this is made by a person, like a machine instead of a person. Also, the last example which I want to bring before I finish is Google Duplex. This is something which I tried to. It was a little bit strange because when it came out, I was super excited about it. Like I said, oh, this is like everyone should know about that. And I tried, but no media actually ever talked about that. Except for some small headlines. And I was trying to publish in LinkedIn, on Facebook, but it got 0 like. And I was saying, why the people are not liking this? This is amazing, And what it is basically an assistant where you could just put something in your calendar, for example, a dinner next week, and then it will automatically, the AI will automatically phone the restaurant and make a reservation for you. So that was pretty cool, I think. But what also was pretty cool, I was really impressed by the quality of the AI things. And we will listen probably 1 minute or a couple of minutes of this. This is the AI itself phoning the restaurant and making a reservation for you. So.
Hey, I'm calling to make a reservation. I'm looking for a table on Friday the 4th.
This Friday?
Yeah. Mm-hmm.
So, how many people? 5?
It's for 2 people.
2?
Yes.
And what time you will attend?
At 7 p.m.
And I your name?
First name is Yaniv, Y-A-N-I-V.
Okay, I got it. So it will be 2 people at table 12?
Yes. Mm-hmm.
Okay, got it. Yeah. Thank you.
Okay, awesome. Thanks a lot.
Thank you. Have a good day. Bye.
Okay, bye-bye.
So
How can I help you?
Hello?
Hello, what's up, man?
Hey, I wanted to know what are your hours for today?
10 a.m. to 6:30 p.m.
Okay, got it. Thank you for your time.
No problem, sir. Bye.
So, I mean, this continue, of course, there are more examples, but I was really impressed by, I mean, no one of those guys probably recognized that he was talking with a machine, basically. Like, because the quality is getting so good, that it's actually getting very, very difficult to recognize, like, people from machine. And indeed, there was, like, a few months ago, there was, I don't know how to call it, it was cool or sad, but it's cool from a technology point of view, it's sad from human perspective, But where basically they use AI to fraud one big companies. So what they did, basically they train a model on the mimic the CEO voice, basically. And then with this model train, they called the CFO of the company, and they told him that some supplier needed money. They need to do some transferring for settling some money, and they basically asked the CFO to make this urgent transfer of $250,000 into account. And then the CFO actually made the transfer, and then after 1 hour, a couple of hours, they phoned it again, asking for a new transfer of $250,000. And at this point, the CFO was a little bit, suspicious, and then he called back the CEO and asking, okay, but why we need to do this? Actually, we just transferred $250,000, and the CEO was completely, he didn't know about anything that was going on. So it was actually a fraud of people, like training models on basically faking the CEO voice, yeah, and everything. So this is an example how also the things have been misused. Yeah, I think that was it. Yeah, thank you. If you have any questions, yeah.
Dette dagens siste foreleser, Zhang, som dataforsker. Og her dypdykket finner sted. Så ordentlig magedrag, så tar vi et dypdykk på slutten her. Vær så god, du.
Yeah. Okay, good afternoon. I am Duo. Currently I'm working as a data scientist at Broentech Solutions. My topic is not about very like scientific fictions application. It's about very practical industrial applications. It's about how can we use artificial intelligence in the industrial process control. So this is my short CV. So before I joined Broentech Solutions as a data scientist, I did my PhD in Oss University of Life Sciences. It's focused on the data-driven approaches for the sewer system control. So I took, firstly, I took some statistics courses. Then the teacher of the statistics courses told me I have to looking at the machine learning and deep learning because this is some state-of-the-art technologies in the statistics and mathematics. So I also took some machine learning, deep learning, and process control courses during my PhD and applied the artificial intelligence, it means machine learning and deep learning technologies in my PhD project. And before that, for my master, I focused on another types of the model, which is numerical models. And my bachelor is about hydraulics, not about IT, actually. In the industrial process control, why we need a model? A model could help us in all the aspects of the industrial control. If we take a look at this very classical feedback control loops, we can find a model can help us for almost any component in the process control. For example, for the set point, we can predict the set points to give the operators enough time to do different actions for the control. For the controllers, we have not only the PID controller, but also the model predictive control, which means we use a model to predict the future behavior of the system. Then the controller can adjusting the control signals. For the actuators, it's just exactly what we did in the tide, which is we can do some anomaly detections for the actuators. The actuators means some devices. We can detect the anomalies of the devices, then avoid the failures in the process. For the process disturbances, for example, in some cases, if we want to use the feed-forward control, then we definitely need a model to estimate the process disturbances. For very complex processes, sometimes we need a model to do the system identification. It means to identify the system dynamics of complex processes. And for the sensors, in many industrial processes, there are some parameters which we cannot measure directly. So we need a model to help us, to give us a soft sensing model. Means we use some easier to measure parameters to estimate some very difficult to measure parameters. So as what I said, I touched two different categories of models. The firstly is called the numerical model. This is the traditional and classical way in many industrial applications, and the the new machine learning models. The numerical model, it's very complex, as I would like to say. It's based on very complex partial differential equations, and you have to use the numerical method to get a solution for the partial differential equations. For example, the finite element method, finite volume method, finite difference method, and any of the method is very, very complex in terms of the mathematical point of view. And another disadvantage of numerical model is it's very, very slow. Sometimes we use several hours to get a solution for a single model. So we can't. It's very difficult to use the numerical model for the real-time purposes. But in the industrial process control, we often want to use the real-time control. So that's why we wanted to use the machine learning, because machine learning is once you train the model, you can use it for the real-time purposes. The machine learning model can receive the input data and gives you the output data almost in real time. And another advantage of machine learning model is we can deploy the machine learning models as a software, as very easy to use software, and we can put it on the cloud. So we have many web-based applications about the machine learning. But numerical models, mostly we have to use the desktop-based software. So that's the advantage of machine learning. And machine learning is a category of algorithms that allows it can predict the outcomes without being explicitly programmed. It's a kind of a data-driven model and a subset of AI. In terms of the machine learning, the state of the art is deep learning, which is also the state of the art in the artificial intelligence. The advantage of the deep learning, why we have made so much progress in artificial intelligence and in deep learning in recent years, there are three reasons. Firstly is because the hardware, we have very powerful computers to help us to train deep learning model. We have some softwares with the mathematicians and artificial intelligence scientists, they improved the algorithms. And another very important reason is because data. We have more and more data. In the industrial applications, the data is mostly come from the Internet of Things. And with more data, with the amount of data increase, the performance of a deep learning model, it usually outperforms the machine learning model. That's why in recent years, the deep learning is getting more and more popular. So the major deep learning techniques, it include the feed-forward neural network, convolutional neural network, recurrent neural network, autoencoder, and the generative adversarial nets. This is the mainstream, the deep learning technologies. So let's firstly take a look at the feed-forward neural network. Feed-forward, as the name, so it have an input layer. The inputs comes to the hidden layer, then going forward to the output layer. So it's like always feeding forward. So we call it the feed-forward neural networks. And in the feed-forward neural networks, we have these small units. We call it neurons. The neurons, it's receiving the input from the previous layer and generates the output to the next layer. Then, according to the difference between the prediction and the true values, it do back propagation. Back propagation means from the output, it calculates the partial derivatives backward, and finally to the input layer. And afterward, the neural networks, it can adjust itself to making the predictions as close as possible to the true value. So through the feed-forward and back propagation processes, the neural networks can improve itself and learn very complex non-linearity relationship between the input data and output data. It's very similar to the function of the human brain. In our brain, we have a lot of this kind of neurons. It's receiving the input data and get the output data. Then we can learn from through the interacting with the environments. So in normal feed-forward neural networks or in normal deep learning models, we have many hidden layers, many hidden neurons, and these processes, the feed-forward and back propagation processes, is going on and on during the training. So through these processes, we can train a model to modeling very complex non-linear narrative relationship. So this is the simplest neural network technology, the simplest deep learning technology called feed-forward neural network. And for image data, people have another neural network technology called the convolutional neural network. An image in the air of the computer is a very big matrix with length, width, and depth. Depth means if it's a colorful image, it has the RGB values with the red, blue, and green, so we can see a colorful image. The convolution means a very special layer. It is scanning through this big matrix, then generates the output on another side. It generates the output through the scanning. So this kind of a scan is very similar to how our brain is processing image. When we see an image, our ear is actually scanning scanning what we see, then processing the data. A typical deep convolutional neural networks, it have do this kind of scanning many times and generate many the outputs, several layers of the outputs, and making the pictures smaller and smaller, but deeper and deeper. With the image getting smaller and smaller, it means it's easier to be processed by the computers. Because if you think an image with 1,000 pixels and also 1,000 pixels for the width, it's around the millions of the input data. So we have to reduce the size of the image, but we making it get deeper and deeper. It means the information of the original image is compressed and easier to be processed. So this technology called convolutional neural network, and it's particularly suitable for processing of the image data. Then we can take a look at it's another technology called the recurrent neural network. The recurrent neural network, it means the hidden layers means this neuron in the middle, the information in the hidden layers is translated from the previous units to the next time step. It's very similar to how we remember or memorize something. When we memorize it means we store some memory in the brain rather than only processing the information from the current time. And we have to notice the recurrent neural network is based on the feed-forward neural network. The only difference is it's pass the hidden neurons from the current time step to the future time step. So we can view the recurrent neural network in 3 dimensions. It means here, if we only looking at time step 1, it's only a feed-forward neural network. But then the information in the hidden neurons, means the memory, it goes into the time step 2, then goes to time step 3 and time step 4. So this technology called recurrent neural network is very similar to how we memorize something. And it's particularly suitable for the sequential data. Sequential data means when we're speaking, the language is a kind of sequential data. When we do the translation, the text is a kind of a sequential data. So when we're translating something, we are not only translating the current word, we are translating also, we're also translating according to the previous word and even the context. So this kind of recurrent neural network, because it can memorize the sequences, the information in the sequences, so it's particularly for processing of the sequential data. The training of the recurrent neural network, we use the backpropagation through time. It means from the output, firstly do the partial derivative to the hidden layers, then to the previous hidden layers, and even backward. So it gives us a very big problem, because after many partial calculating many partial derivatives, the information from the very early step will have very little influence to the current information. It's just like a human don't have very good memory. It can only memorize a very short period, but it cannot have very long-term memory. To improve the memory of the recurrent neural network, we invented a very special kind of a recurrent neural network called long short-term memory. So this is a typical example of the application of long short-term memory, the Google translation. So as what I said, it's particularly suitable for the sequential data. And this is the secret behind the long short-term memory. So it's in the hidden neurons, in every hidden neurons of the long short-term memory neural network, it has this kind of gating mechanisms. The gate is responsible for forget something, remember something, and transfer something into the next step. It's like we human have a small notebook. Whenever we have something very important, we just write it on the notebook. If something is not important to us, we can forget it. So we can have very long-term memory. When we're processing the current information and need some information from a long time ago, we can take out the notebook to to help us memories and processing the current information. So this is some schematics of the long short-term memory neural network. And next major deep learning technology called autoencoder. The autoencoder, it means the input data and the output data is the same. So it's a kind of unsupervised learning method. An autoencoder have two parts, the encoder and the decoder. The encode part, it comprises the original high dimensional information into a very small dimensional information. And the decoder is responsible for reconstruct the original data based on the compressed data. So here are a little application of autoencoder. So if I don't tell you, do you know which one is the real image and which one is the image generated by the autoencoder? So we can't distinguish it. It means the autoencoder successfully reconstruct the image. Actually, I also forgot which one is the real image and which one is generated by the autoencoder. Another application is if the input data is some noisy data, the output is clear image. The autoencoder can help us remove the noise from the image. So then after introduced so much theories, maybe this is the time to introduce some practical applications. I will introduce two projects. The first one is about my PhD project, and the other one is a project at Broentech Solutions about the hydropower stations. My PhD project is about the sewer system. Because the more and more heavy rainfalls and urbanizations and the broken sewer pipes, we have a lot of problems about the sewer overflow. Means the wastewater is too much in the sewer and it releases to the rivers and to the oceans, polluting the environments. We have two options. The first option is to just construct new sewers, and it needs a lot of money. And because of the urbanization, we don't have enough space to do the construction in the city center. So my PhD project is to use monitoring, modeling, and control to reduce the sewer overflow. We need in these options, we need not too much money. We still need money, but it's much more cheaper than construct new. We only need some instrumentations and models. The technical roadmap is we firstly have a monitoring system to collect the data about the sewer. Then, according to the data, we developed some models and use the model to get some new knowledge about the performance of the sewer system, and use the new knowledge from the model to improve the sewer system control. So, as the first part of my PhD, we distributed many this kind of sensors in the sewer system, and after we collected many data, and after my statistic teacher told me I have to look at machine learning and deep learning, I wrote this paper. It's a proof of concepts. It's using the long short-term memory to enhance the time series predictions, and the time series data is from this IoT system. Because as what I mentioned previously, the long short-term memory is particularly suitable for processing of the sequential data. Sequential data not only means the translation, but also means the time series. When we're doing the translation and predicting the time series, the function of our human brain is something similar. So that's why I tested the performance of long short-term memory for the time series prediction, and it's according to my to my research, it's better than the traditional method. So after I found the long short-term memory is very powerful for the time series predictions, I further did this research. It's like in the sewer system, we have a lot of big sewer pipes. When the rainfall comes to the city, some of the big pipes, maybe it's still empty. It's not full because the rainfall in different parts of the city is different. Then we can close the pump of this pipe and use the pipe itself, use the big pipe itself to accumulating the wastewater. If we have two lines of the sewers, this one is full, the other one still empty. We can close this one and letting the wastewater in the full pipes go first, then the empty pipe go afterward, so we can reduce the overflow. We used the traditional way, the hydraulic model, to test which part is empty and how can we control it, and use the long short-term memory neural network to predicting the flow in the sewers, so that we can give the information to the operator to enhance the control of the sewer pipes. Then we further did another research. We have this pilot project in Drammen. In the Drammen, they have two wastewater treatment plants. We proposed a method which is to transfer part of the wastewater from this treatment plant to the other treatment plant. So it means if this treatment plant is full, we can move in some wastewater to another bigger wastewater treatment plant. And again, we use the traditional way, the numerical hydraulic model to do the test. And here you can see, here this is the hydraulic model we developed. As you can see, the hydraulic model is very complex. So every single line, you have to you have to draw every single line in the software. The length of the pipe, the slope of the pipe, the material of the pipe, and the cross section of the pipe. So it's a very complex model, and it takes several hours to finish one single simulation. So that's why we can't use this model directly for the real-time control. And after we tested the idea with the hydraulic model, we used also the long-short-term memory neural network to predicting the flow to this treatment plant. So because if there are a lot of flow comes to this treatment plant, the operator have to open the pump to lighting the wastewater transfer to another wastewater treatment plant. So that's how we use the AI technology together with the numerical model in the research. And this is finally the final papers from my PhD. It's about we found the hydraulic model. It gives us a lot of information, but it's very slow. The artificial intelligence models, we have to making the predictions size by size. It means we have a single water level prediction model, a single flow rate prediction model. Then we developed this model. It's collecting the water level information from 8 CSO, it means combined silver overflow structures. And this model, it's receiving not only the temporal data, but also the spatial data. Means it receives the data from the 8 combined silver overflow structures at the same time. Because there are some relationship between these 8 CSO structures. If the upstream structure have a higher water level, it will influence the downstream structure. So we use the inputs from the 8 structures together feed into the neural networks, and the neural networks learn the correlationships between the 8 structures and gives the output individually. This technology called multitask learning. So this is the last paper from my PhD. And another application is about tide. It's what we developed at Broentech Solutions. It's an anomaly detection software for the hydropower plants. So this is the user interface or the dashboard of the tide. We can check the real-time information for many different sensors through this dashboard. And a better thing is you can design the dashboard by yourself. You can drag and draw any sensors you want to monitor into this dashboard to making your own dashboard. So the technology behind the anomaly detection is called the autoencoder, as what I mentioned previously. We use normal data to train the autoencode model, and use the reconstruction error, means difference between the input and output, as an indicator of the anomalous levels. If the reconstruction error is very big, it means the combination of the sensors is never seen by the autoencoder before. It means something never happened. There are something never happened appears in the hydropower plant. It means we have higher probability of anomaly situations. So this is the principle of the anomaly detection software TIDE. And we used boosting training mechanisms. It means in the original data we collected, there are some it's not anomalies. It's some failure, some outliers due to the system itself. So I used another algorithm called isolation forest to remove this kind of outliers. After remove the outliers, after these pre-processing procedures, we feed the most normal data into the autoencoder to train the model, to light the model during the anomaly detection tasks. And here is some example of the user interface in the software. This is asset diagram. It displays all the assets in the hydropower plant. If you click any of the assets, for example, if you click the transformer, stator, or the rotor, you will get an interface like this. The different colors, it indicates different types of failures or anomalies. For example, this one, it have the anomaly score, means the score from 0 to 1, is higher than the normal period. It's a little bit higher, but it's not very high. Then it's in the pink color to indicate maybe something happened here, and the operator must check this situation. And we also have this very big, very high anomaly values. It means something very serious happened. The operator must take a look immediately. So this is a user interface, and we have different types of the anomalies to give the notifications to the operator. So if we take a look at this big anomaly situations, we can check in the sensor values one by one. I mean, not only checking all the sensor values, but we can check in the sensor values one by one. So the operators sometimes even don't need to go to the field. It can check what happens and which sensor or which devices have failures remotely. And also we have these small anomaly situations. And if we check in the long-term, the trend of the data, we can find this the data during the small anomaly situations. It's really different from the most of the period. It means the model have enough sensitivities, and it's robust enough. And finally, this is a function we are developing called AI sandbox. It means we can manipulating the sensor data and test the model's performance. It means because in some hydropower plant, there are very little anomaly situations. And we can't waiting for 2 or 3 years until the anomaly situation happens. We can test the model by ourselves through manipulating some of the sensor data. Then the perspective. Finally, it's the perspectives. So I talked about the deep learning technologies, and I personally believe in the next step for the industrial process control, a technology we should look at is the reinforcement learning. The reinforcement learning, it means the agent, you can think of the agent as a small robot. It's interacting with the environment surrounding us, and the agent can learn to take the actions by itself to get the maximum benefits. So this is the principle of the reinforcement learning, and I will demo this classical reinforcement learning algorithms called dynamic Q-learning through a very simple example. So the purpose of this demo is to lighten the agent. You can think it's a small robot, find the shortest path from the starting point to the end point. But during the, in the middle of the demo, so this gray box means a wall. So the robot cannot go directly through the wall. It has to bypass the wall. In the middle of the demo, we will remove a piece of the wall. So the shortest path between the starting point and the end point, it changed in the middle of the demo. And let's take a look at the selections of the small robot. So at the beginning, as we can see, the small robot found the shortest path. The yellow power means the strong recommendations means you must take in this way. You must go into this part in order to get the shortest path from the starting point to the end point. And suddenly, we remove a piece of the wall, but without telling the robot. And you can see the robot's new choice. It means the agent or the robot itself, it's interacting with the environment fully automatically, without any information from the human, and it finds the maximum reward. In this case, the shortest path between the starting point and the end point by itself, totally by itself. So that's why I see this reinforcement learning technology is very suitable for the industrial process control, because it's fully automatically, to control some very complex processes. For the very complex processes, we can combine the deep learning with reinforcement learning. It means we use a deep learning neural network to predict the state of the agent. It's like the deep reinforcement learning is the technology behind AlphaGo. Why AlphaGo have get the success? And because the Go game is very complex. We humans don't know what is the relationship between the input of the Go game and the output. But through this neural networks, it can learn the relationship between the input and output. According to the input and the output, the agent can select some actions to interacting with the environment and get the maximum benefits. So this, well, I think we already get success in AlphaGo, and we can get more success in the industrial control by combining the deep learning and the reinforcement learning. Okay, thanks.
Thank you very much, Duo. Jeg regner med alle fikk med seg alt av dette her. Selvfølgelig. Ja. Det var altså dagens dypeste dykk. Så har vi i hvert fall vært der og kikket. Tusen takk for spennende foredrag, Duo. Da tar vi 10 minutter pause.